Good afternoon, everyone. Welcome to this webinar, the first of the Advanced Design Week series. My name is Sara Santana Herrera, and I will be giving you an overview of how to design and detail concrete members in Advanced Design. I work as an application specialist. I look after structural analysis softwares like our main product, Advanced Design, within the Greatech UK branch. If you have any questions arising from this webinar, you can contact me directly through my email, through our support platform, or via LinkedIn. Today we will be looking at several topics. First topics around advanced design. How to set the design parameters for reinforced concrete members, how to create element groups. This one is useful for walls if you want to design a group of walls at the same time. Also design groups, which allows us to group columns and supports and assign them the same design parameters, and then we can have a bill of materials, reports and drawings for this group. Then we will be looking at the Beam Designers Concrete series, how to design a beam, a column, foundation, a wall inside this application, and how to briefly how to create design templates to speed up our work. So for those who are not familiar with Beam Designers, it's a series of tools that can be used within different platforms. So you can use Beam Designers as a standalone software, but also with Advanced Design, which we'll be seeing today during this webinar. Also, you can use it within Revit, mainly for concrete members, and with Advanced Steel for the steel series, which is stairs and railings. So it's a very flexible tool. We cover beams, columns, foundation, walls and slab within the concrete series. Within the steel series, steel connections according to Eurocode 3, stairs and railings, and the structural designer, which is a very useful tool to create in a few clicks a wall steel structure. Now, how to create a design template with Beam Designers. You need to open the Beam Designers standalone software first. Then you can set all the parameters, localize them depending on the country you're working in. And then you have different options. You can apply these settings to AD, Advanced Design, or Revit, selecting from the menu the already created design templates. So you have design templates for each module, which means you can create a design template for beam, for column, for footing, wall, slab, and so on. And then you can just choose which one to use when you are doing your design. So today I will be showing you all these features using a multi-story office building that you can see on the screen. And then once we have covered all the topics in the webinar, we'll have a Q&A session, and you can make all your questions or just send them to me via email or via LinkedIn. Okay, so this is our building. As you can see, I have in here different levels, okay, with all the elements inside the model. I have created a columns design group. You can see it below. So this group contains a master element, which is this column. Okay, you can see master element, this column. And then all these other columns are the slave elements. I will just isolate this group, you can see here. So this is my master element, and my slave elements will be following the design of this master element. This allows us to speed up the work significantly, because we just issue one calculation report, one drawing, one bill of materials for all these columns. Of course, you can group as many columns as you wish in one group. It just depends on the utilization of these columns inside the project. Okay, just display everything again, just hide the loads. Okay, so if you want to create one of these design groups, it's very easy. Just go to design group, select the master elements and then the slave elements. As you can see, this one has all the local design parameters in here. Still the utility of the rebars. I have the concrete covers, correction of cracking automatically by advanced design, and then you can set all these parameters if you want to consider fire verification, and some other parameters. So these are the local design parameters. You can set them for each element. So if I select another one, let's say this one, this column, you can see we have the same list of parameters. And also you can set global parameters for design. So we have here options on how to calculate the planar elements. Okay, the stress strain law for reinforcement, safety factors. If you want to consider fire verification, which type of strength, okay, class as well. You also have options for shrinkage and creep. Then if we go to beam calculation, you can set the number of bars, maximum diameter, number of layers. Columns calculation, we can set the buckling parameters from here, detect the super element buckling lengths automatically. Reinforcement, you can select the diameters you want to use for the rebars, fabrics if you're working with a slab, punching verification, and then the calculation sequence, meaning if you activate any of these, the software will do them in a specific sequence. So these are the global design parameters from advanced design, and the ones I just showed before are the local, or let's say individual design parameters. This one regard only each element you create in advanced design. So of course, when I group my elements in a design group, my slave elements are automatically affected, or let's say defined, by my master element. I also have the option of using the design templates from BIM designers. So I have here in the footings, if I select this one, you can see I have this option, BIM designers templates, and I have selected UK default footing. That's for my isolated foundation from BIM designers. But if I go to this one, I haven't selected anything. So typically this one will be already using UK parameters for the design, and also for drawings, schedules, bending details, and so on. Whereas this one, I have to set these parameters manually when I open the BIM designers application. So that's a difference when you use a default, let's say, a template, and when you don't use it. Right. I also have created groups of walls. Okay, so I will show you these ones. So these are shear walls inside the building. I have two groups of this. Okay. Let me just. So this means the four walls will be designed at the same time because I have created an element group for these walls. Okay, so all the efforts, internal efforts from advanced design will be directly taken to BIM designers, and I will be able to create a drawing calculation reports for this group of walls. You can see it's here enabled calculation following the group. Okay, so that's for the walls. And then the beam will be a classic beam. I will just select one beam from the building, and you will see how to do this process of design inside BIM designers. Okay, so overall I have created a few loads, so dead loads and live loads, typical values for the usage of this building, and a few combinations according to Eurocodes. So I will just open the already created analysis model, and I have saved a few views so we can go through them. We can browse and see how is the behavior of this building. Right, so all these views, of course, you have to first select the type of result from the list, from this drop-down list, and then for which type of element, if it's support, if it's a linear element, if it's a plate element, and then just say view, and you will be able to open this anytime you want, and also use these views in a calculation report. So I have displacements here, 5.2 mils. Resultant forces for this group of walls. That's another advantage of using the group of walls. You have resultant forces for the group instead of for each individual wall. Bending moment for linear elements. Okay. Support reactions, vertical reactions, and then I have selected stresses. Von Mises stresses, top and bottom layers, and then reinforcement, bottom layer X and Y for this slab. Also crack widths following X and Y directions. All these reinforcement and cracking weights are displayed by using this toolbar, RC Design Results. Okay, you have all the results in here. Type of results from there, and then if it's for a linear element or a plate element. Concrete stresses, concrete deflection considering cracking for this slab. So this is from advanced design point of view, or the visualization of results, FEM and RC design results. Now let's go to the design part. We will start with the columns, the group design group I created. So I will just double click, and I will be immediately taken to the BIM Designers interface, which is slightly different to the advanced design one. Okay, so we are now in the advanced BIM Designers interface. As you can see, I have a view, 3D view of my column. This is the master column, and then I have an elevation view and transverse view, or let's say section view. And if I go to loads and combinations, I will see all the internal efforts for each one of the columns in the group. You can see how the values change as I browse through the different columns in the group. Bottom loads, top loads, both are coming from Advanced Design. And in the Combinations tab, I can see all the combinations used for the design. So both ULS and SLS are listed in this table. Okay, so now I can take a look at the different options we have within the design of these concrete columns. General assumptions you can change from here. Reinforced concrete class, I have this 3037 class. Ductility of steel rebars, also design assumptions such as seismic dispositions if you want to consider them. Also bending moments tolerance value, fire resistance. At the moment I'm not calculating fire resistance for these columns, but of course you can do it. Concrete covers, we have 3 centimeters. Okay, so that's all good. Geometry, if you need to increase the size of this column, you can also change it from here and then update your advanced design model afterwards. Buckle lengths and so on. We have also reinforcement settings. So longitudinal, I can specify the maximum spacing. I can also specify if I want to use hooks, if for all the rebars or only for a few of them. Also mandrel diameters for bend bars, transverse reinforcement, minimum, maximum diameters, also close links, the details in here, spacing of rebars if it's uniform or if I want to calculate like different packages as is shown in here. Top and bottom starter bars also can be defined from here. So that's from a design driven rebar layout point of view. If I want to do this from a detailing point of view, I can use the reinforcement tool and then really select the number of layers I want to place, bars diameter, and then just check if theoretical reinforcement is enough. I mean, if the real reinforcement is enough in comparison to the theoretical one, if I'm providing the sufficient reinforcement for this column. Main, lower, so that's for bottom bars, top starter bars. I also have the transverse reinforcement, so because I have already placed some reinforcement in here, if I go to main, you can see I have 4 spaces of 12 centimeters, then 6 bar space of 29, and then again 4 of 12. You can change all of this if you wish, and then just click on apply, OK, and the software will update the rebar layout considering these configurations. Okay. Right, so I have calculated these columns reinforcement, and I have created a nice report. So you have different options from here. The reports look like this one. It's a very detailed one. You have, of course, geometry details, and then combinations, global assumptions. I have here the list of columns being designed in this design group. Materials, all the parameters with regards to the covers, minimum constructive dispositions, and you can see every time we have reference to the Eurocodes sections and formulas. Interaction curves, we can see it as well from the graphic interface. Envelope of these values, moment, axial force, shear verification, and then at the end you have a bill of materials for the whole design group. Okay, so interaction curves can be seen from here as well. You can see everything is checked, verify. I also have a few diagrams in here, and also the drawing. So drawing, very important. You can save it as DWG or as DXF file, and then open it with AutoCAD with any other application you would like to use. Right, so this is all for this design group. Now I will close this one and we will see how to do the design of a wall group. So wall group is already created. I have it in here for the second level of this building. Okay, let's take this one. Okay, update, calculate all. Then we will see how the rebars are placed for these wall groups. So these are core walls. I have two groups. One is in here, the other one is in there. After a few seconds, we'll be able to open the interface of BIM designers, and we will have more or less the same options we have with the column design module. So we'll be able to change the geometry of the walls inside this group if we wish to. Also set the design assumptions, reinforcement settings, and create a report as well. Okay, so this is my, I have a few errors and warnings apparently. Okay, I have under loads and combinations again my internal efforts coming from advanced design. So this time we have resultant forces, okay, at the bottom of the wall. I can also display them at the top of the wall. So this is wall 1. I have these values in here, and then wall 2, you will see how it changes. Okay, wall 3, and so on. And this one are the group resultant forces, so the ones used for the wall group. Okay, combinations again, list of combinations used for this wall design group. That's all good. Now let's go to design settings. I also have possibility of changing my safety factors, my concrete class, if I want to consider seismic dispositions or not, buckling assumptions, ductility class of my steel rebars, concrete covers, same as for the column 3 centimeters. That's all good. Geometry, again, I can change this if I want to. Wall geometry, okay, if I want to consider an upper slab, lower slab, below, or on top of any of these walls. Okay, now let's take a look. I have to check interaction curves. That's what the software is telling me. So I just have to hit interaction curves. We will see all the checks for this element group. So everything is very well verified. Okay. I have also the option of displaying diagrams for any wall inside the element group. Okay. And of course I can create reports for this wall if I wish to. Okay, so it will look like this one. I have already saved this before. So you'll see geometry, all the walls described, loads and combinations, assumptions, materials, concrete covers, all the walls are reinforced. Okay, these are shear walls, and as we see, we have all the reference again to the Eurocodes. Okay, out of plane verifications, reference to the Eurocodes, combinations, second order effects. Okay, and at the end we will have a bill of materials for this element group. Interaction curves verification, of course, and then bill of materials for all these walls. Okay, right. So I don't have the warning anymore because I have already checked the interaction curves. Now what I can do is save these walls and then jump to a beam design. Oh, I just forgot something. We have also options from the detailing point of view. So again, you can change any of these parameters to comply with your requirements in terms of detailing. Okay, linkage as well. We have U-shaped bars, edge bars, slab start bars, and so on. Right, so let me save this, and then we will go to the other model, which is the beam design. Okay, I have a lot of beams in here. Let's select this one, let's say number 1. And again, we will have more or less the same options we have been seeing with both the walls and the columns. Okay, so again I have 3D view and then elevation and cross-section view. This one is not calculated, so you will see at the beginning only loads appear in this part. Okay, so internal loads, dead load, live load, bending moment, shear force, axial force. Combinations will appear once I launch the calculation. Geometry, you can create depressions, openings as well. Also change the position of beams. Okay, reinforcement settings, you have many options from here. Anchorage, anti-crack, transversal, longitudinal. Also special features if you want to specify number of bars per layer, diameter of top bars, and so on. You also have the detailing tool, okay, in here. So you can play around with all these options. Now I'll just hit the calculate button, see what is done by beam designers. Okay. Right, so I can see I have a problem in here with the cover. Let's go to design settings, concrete covers. Yeah, it's actually too big cover. I'll put 3 centimeters. That's a better thing to do. Calculate again. Okay, now I have a nice reinforcement layout in here. You can change the position of this transverse view. Let's say I want to put it at 0.5 meters, and you can see how this cube moves, and we have the option of see what's going on at this part of the beam. Then we have all the calculation results in a summary style here. I also have my different tabs with bending moment, shear forces, reinforcement, longitudinal and transversal, deflection values, stresses, support verifications, support reactions, and of course my drawing. So again, you can save this drawing as a DWG or DXF file and then open it with AutoCAD, for example. And I can add bending details, for example, to this drawing. So I just have to select it from here. We're using again the bar schedule, typical bar schedule for the UK. That's okay. and then you will see how the drawing is updated. More seconds. Okay, great. Of course, you can customize this the way you want. I have here my schedule again, and of course I can create a report, calculation report for this beam. I won't do it at the moment, it will take a few seconds. You already know how do they look like. So you can see now if I go back to loads and combinations, I will have my list of combinations appearing. Okay. Right, so now last module we will see today is the footing module, mainly covering spread and isolated foundations, so foundations of walls and foundations of columns. I will select a foundation of column. Remember, I did use for this one the template, Beam Designer's template. So let's take a look at what it does. I just double click on it, and again I will be in the Beam Designer's interface in a few seconds. So in here you can specify soil layers. The template already comes with soil layers, or you can modify this as you wish. Okay, so update, that's all good. And then if I go here, you will see under soil profile, I have a customized series of layers. Okay. I also have in the design settings possibility of considering seismic bearing capacity. For example, I have possibility of calculating the settlement if I want to verify it or not, sliding, overtoning, and all these other stability calculations. General design assumptions, minimum reinforcement area, it's already defined at this value. Concrete covers 3.5 centimeters, that's a good value for this foundation. And I also have class and ductility of my steel rebars. Okay, let's say that's all good. Apply OK. Reinforcement settings, again you can specify here hooks, reinforcement, also rectangular for the starter bars in here. Okay, I would just keep the default values and then hit calculate, and we will see in the summary everything is okay, bearing resistance is okay, I don't have any errors or warnings. Of course I can optimize this rebar layout, play around this design settings, and of course soil profile will be an input, so you can't really play with that. Also have my results in terms of analysis diagram, compressed area in here, stability, overtoning, sliding, there's no eccentricity at the moment, compressed surface is okay, and I have a drawing as well. So parameters of the drawings came directly from my design template. So you can see again I have BS8 666 bar schedule, drawing style, bending details. If I want to add them, I can add them. But all these parameters are coming from my design template, so it really speeds up the process of designing and creating the drawings. Okay, and of course you can create a report from here. I have already saved it. I can show you now. Okay, so we cover, as I said, isolated footing, which means footings on columns, foundations of columns, sorry, and spread foundations in this module. Again, I have all the loads and combinations considered for this foundation, concrete covers, soil parameters, cohesion, weight density, and so on for the bearing capacity. sliding, overtoning, longitudinal reinforcement, all references to the Eurocodes, so you can check anytime. Stored on time method, spacing, and then I have a nice drawing at the end of this calculation report, punching, shear verification as well, and then of course my bill of materials. So this is all I wanted to show you today. We also have a slab module embedded in Revit, but that's a topic for another webinar. So those of you who want to know how to design and detail slabs with analytical results from advanced design, this will be covered probably in the future in another webinar. And well, thanks for attending. Of course, once you close this, the advanced design model is updated, considering all the modifications you have performed during the design and detailing process, and you can have a final report of all these elements and all these results in one place. So thanks for attending again. I hope you enjoyed, and see you soon.